We're going to look at the idea of similarity, and we'll also bring in some scale factor. I drew the first couple of diagrams that you have on your paper up here on the board. Granted, the ones on your paper definitely look a lot better as far as seeing how they're similar, as far as just looking at a good looking shape there. Similarity. Right, we see similarity all the time. Similarity just means that, hey, this object is a scaled down version of this object. Probably some of the most common things would be like a map. If you're looking at a map of a state or of a country or even like a globe, something like that. Obviously not the same size as the real thing, but it is a scaled down version of the real thing. Another good one would be design plans, room design plans, house plans, things like that, where they're all laid out on a piece of paper versus the actual size of the house. So that scaled down version. We're looking at objects that are scaled down from its similar part. So, first one here. I've got the two triangles here. And again, not drawn perfectly, but you can definitely tell on your paper that this one is smaller than this one. Okay. Let's try angles matched up here. This angle is definitely the same as this one, vertical angles. And the way that this would be similar, visualize this triangle up here rotating around to this triangle. So rotating around would make Q, I'll put two markings, similar to K, or actually would be congruent. They're the same size angle, just the distance are scaled down. And then P, I'll put three markings. It's going to be related to R. So again, visualize this rotating around. Now we got to get our statement written in the right order. This one went QZP. So QZP. So I need to get the one matching up to Q first. So if it's rotating around, that would be K, Z, and then P is relating to R. That would be the order. And I need my little triangle symbol there to indicate I'm talking about a triangle. The second pairing, triangle, GRN, is similar to which triangle? All right, or the name of that triangle. So again, this one's the smaller version of this one. So G corresponds to H. R corresponds to K. N corresponds to S. Okay. So again, I'm just putting the 1, 2, and 3 markings so we can keep the pairs together. So when I write the letters in the correct order, G was first here, one marking, so H is first. R was second, so K is second. M was third, so S is third. That would give me the markings or the order of the letters compared to those corresponding markings. All right, our next pair of figures is asking us for a scale factor. And a scale factor is referring to the size relationship between each, right? So in the case that we have here, I'm just looking at the scale factor of the left figure to the right figure because it's asking me in the instructions the smaller to the larger. So in both situations here, smaller to larger, smaller to larger. Okay? So scale factor, I'm going to find my sides that relate to each other or correspond to each other. This 32 corresponds to the 40. Now I see some other numbers here, but I've got to make sure I'm looking at which side corresponds to that 32. That would be the 40. So the scale factor would be 32 over 40. That is my scale factor. Now, most of the time we see scale factors in a reduced form. Right? So I can reduce this fraction. 8 goes into both of those. It'll go into there 4 times, into 45 times. So I would say the scale factor is 4/5. That is perfectly correct. We use fractions a lot in mathematics to represent things. It's a 4/5 scale factor. However, sometimes you'll also see it written like this, 4:5, relating that 4 to 5. Either way is correct. Typically, we just kind of stick to the fraction in math, but there's nothing wrong with writing it in this format either. I go to my second set. This 7 corresponds to the side of 21. So my scale factor would be 7/21, and that reduces to 1/3 because 7 will go into both 7 and 21. So that would give me a scale factor there of 1/3. All right, on our next couple diagrams, we're going to take this a little bit further and find our missing side as well as a scale factor. So the key is still get your sides, which corresponding to each other, which side corresponds to the other. So, and again, these pictures not nearly as good as what you have on your paper, but this question mark corresponds to 28. The 40 corresponds to the 32. 30 to 24, 30 to the blank. So what I'm going to do first off is I want to create a proportion. And so instead of a question mark, I'm just going to call this guy X. Okay. So my corresponding pieces would be X to 28. So X over 28 equals, and I'll go with another pairing I have. I could use 40 and 32. Those are corresponding. I could use 30 and 24. I can't use this one because I don't know this guy. So I can pick one of the other pairings. I'm just going to go with the 40 and the 32. I need those corresponding pieces. Now I've set up a proportion. Okay. Solving a proportion goes back to what we've previously done. I can do 32 times x equals 40 times 28. And so 40 times 28 is 1120. Divide by my 32 now. And that will give me x is 35. So I have solved for my missing side. That's the piece I was looking for. That's my missing piece. Scale factor. Okay. We write scale factors smaller to larger. That's typically how we're writing them. And so when I look at this, hey, this is the smaller one. Here's the larger one. Okay. I already have a known piece. Look at the relationship I made in my proportion. I'm going to use that for my scale factor. So this first part is that missing piece. Now let's get my scale factor. It would be 32 over 40. I just took my known fraction there, my known corresponding pieces, small to large, so put the 32 on top. Now I'm going to reduce. That'll reduce by 8. So we're back to that 4/5. The second one. Again, I'm going to put an X where the question mark is so I can set up my proportion so I can solve for X. So my missing piece. X corresponds to 24. So there's my first part. X is corresponding to that 24. Now my second part. I've got to pick a known pairing or a given pairing that I would have. In this case, I could go 40 to 32, and I could use the bottom. They just happen to both end up being 40 to 32. Okay. So I'm going to have 40, 32. So I had x on top on the left, 40 on top on the right, because that's both dealing with this figure. And then my two bottom ones. And now I'm ready to solve. 32x is 40 times 24. Oh, let's see, 40 times 24, 960. 32x is 960. Divide by my 32. X would be, hit the right button here, 30. Okay. So my missing piece is 30. Scale factor. Again, small to large. I'm going to go to my known fraction here. Small to large would be 32 over 40, which again would be 4/5 reducing there. All right, let's look at these next three pairings. Still same thing, missing piece, scale factor. Let's work on that missing piece. I'm going to line my sides up. In other words, meaning I'm going to get my corresponding ones matching up. X minus 4 corresponds to 10. So x minus 4 over 10 equals. Then my other corresponding sides are 8 to 16 or 6 to 12. It doesn't matter which one I use. Okay? I'll just go 8 to 16. There's my proportion to solve now. So I'm going to have 16 times x minus 4 equals 10 times 8. So 16x minus 64 is 80. I'll add my 64 over. If I add 64, I'd have 16x. It's now 144. And then divide by my 16. Should be 9. Yeah, 9. X is 9. All right. X is 9. On the past couple of problems, we were just finding x. All right. Now it's saying find the missing piece. All right. X is 9. So the missing piece right here is actually 9 minus 4, which is 5. That's the missing piece. So this time I have x minus 4, not just an x. So although x is 9, if I put that back in, 9 minus 4 is 5. There's that missing side. Scale factor. I still will take my known fraction. Small over large. It's already set up that way. 8 over 16. Scale factor is 1/2. Second pairing, which would actually be number 16 on your paper. 28 matches up with x plus 9. So I'm going to go 28 over x plus 9. Work on that missing. And then 12 matches up with 9. There's those corresponding pieces. So when I'm saying matches up, I'm referring to a corresponding. I meant to put a 9 there. You have a 9 there on your diagram. 12 corresponds with 9. 28 with the x plus 9. Now there's my proportion to solve we've worked on. So we have 28 times 9 equals 12 times x plus 9. 28 times 9 is 252. There's some bigger numbers here, but we have a calculator. Equals 12x plus 108. I'll subtract my 108 from both sides. That'll give me 144 equals 12x. Divide by 12, x is 12. X is 12. Remember, that's not the missing piece. The missing piece was actually x plus 9. So this would be 12 plus 9, which is 21. There's the missing piece. I have my x value, substitute my x back in, I'll get that 21. Now the scale factor. 12, 9. I'm going to go back to that known fraction. Remember, we want to go small to large. So I'm going to put the 9 on top for my scale factor. 3 go into both those. 3/4 would be that scale factor for small to large. Number 17 on your paper was actually my mistake. It's the same diagram as number 16, so it's the same one again. So we're going to skip on to number 18 there for your notes. Corresponding pieces. 24 goes with this one, so corresponds to 4x minus 4. So for my missing, I'm going to go 24 over 4x minus 4 equals 30 corresponds to that 25. Match up the sides. There are corresponding pieces of our similar figures. Now solve the proportion. 24 times 25 equals 30 times 4x minus 4. So 600 equals 120x minus 120. If I add my 120 over, I'll get 720 is 120x. And then divide 720 by 120. That'll give me 6. So that's my x value. If I put that back in here for x, 4 times 6 minus 4 is 20. There's the missing piece. Missing piece means that missing side value, which in this case will be 20. Scale factor. I just used it once again, my known fraction, my known corresponding piece in my proportion. I'm going to look right back here. That's when I'm creating my scale factor. There's my known corresponding parts. I'm just going to do small to large, so I'm going to put the 25 on top. So small to large, this reduces to 5, 6. Okay. Now I did small to large on each one of the scale factors, just to kind of stay consistent there. If I was asked what's the scale factor large to small, 2 over 1, 4 over 3, 6 over 5. If I'm asked for a scale factor large to small, the larger number's on top. If I'm asked small to large, the larger number's on the bottom. It just depends on which way I'm asked. Typically, we go small to large, but if you were ever asked large to small, just put that big number on in the numerator. Put it on top.